me okay? Yes? People via Zoom, I'm not sure if they can tell us if they can hear us okay. Maybe thumbs up. Yeah, we're good? Okay, great. So my name is Marcelo, and I'm here to talk about do-it-yourself NLP, or how no-code tools can help bridge NLP technology and business use cases. So about me, my name is Marcelo Bursztein. I'm founder and CEO of Novacene AI, and I left my email address. So please feel free to reach out to me in the next few weeks if you find this talk interesting and you want to continue the conversation. I'll be happy to receive an email from you and chat more. Well, let me get this out of the way. I'm not a technical person. Some people say I'm dangerous enough. No, I know enough to be dangerous. There you go. That's how it goes. But the reality is that I've been building digital products for over 20 years now, primarily for public sector clients. And my background is been in UX design. So as a person in UX design, I've always been pulled into the intersection between business and technical teams. Business will bring their business requirements, and we will have to translate them into functional requirements so that the technical team can build products that the business can use and, most importantly, sell to customers. And a little bit about Novacene AI. We build a SaaS platform that enables business users to bring in their data and to apply AI to that data without writing code. If only were that easy. In the last couple of years, through the building of the platform, we realized that what initially started as a vision to abstract complex technology behind elegant interfaces, the reality is that AI is really difficult, and you really have to work at the problem to get it right. So what happened is that our tool turned into a platform for collaboration between business users and data scientists. And that's where we are today with our tool. About the talk, this is going to be about a 20-minute presentation with 10 minutes Q&A. And just about that Q&A, I mean, please ask questions. Yes, I will take questions. But also, if this talk sparks any thoughts and ideas that you want to share here, please share them. I'm here to share my experience here with you, but I'm also here to learn from all of you and everybody on Zoom as well, please. I'm going to present two case studies that demonstrate this type of cross-discipline collaboration from teams coming from very different backgrounds. And I'm going to also explain the benefits that that collaboration created for both teams on both sides of the domain expertise divide. So no-code tools. Raise your hand if you used or are used in the past no-code tools to do your job. Oh, 1, 2, 3. How do you feel about it? You can give me some body language.
I used it for planning, and I use it for. I used the no-code part of the NLP, and then after I realized it's good for me, then I ended up using it for.
Okay.
Could you summarize? Stand a little closer.
Okay, great.
Summarize.
Okay, perfect. So I hear that you started using no code, and then you moved to using the backend. Is that?
I use the API for entity recognition and analysis. So I realized it's good for me. I started using the word version. And then I realized it's good for me. I moved to the actual code because I wanted to run it in a scale, so I didn't run it in a scale at so.
There you go. Gotcha. Okay. And you, what was your opinion? Yeah or nay?
So exact functionalities, like there is upsides and downsides to it.
Okay, great. So what I'm hearing is that I started with no code. It got me somewhere there, but then I really had to bring it back to the real thing to do the rest of it. Something like that, right? It's good for a start, but not for the whole way. And you know, I felt the same way throughout my career. I always felt like no-code tools were limiting. They were limiting me and my creativity and my ability to solve problems. And you know, I have an anecdote that goes back 15 years ago. I was running a creative department at the time, and we had visual designers, and this was a very particular team in that they were very technical. You know, they were not just graphic designers, but they also wrote code, and they checked in code into repositories, run version control on them. So it was a fantastic team, and we brought a tool called Dreamweaver, and I'm not sure if you guys here are old enough to know what that is, but Dreamweaver was made by Macromedia a long time ago, and then Adobe buys it in mid-2000s. And the promise of this tool was, this tool allows designers to create websites by just dragging and dropping elements into a canvas, and then magically the tool creates the code. And I remember we brought that in, and as soon as the designers will switch to the code view, they did not like what they saw. They saw dirty code, bloated code, and they did not want to check that into the repositories. They said, you know what, not good. And those who continue using it, they were using it as a glorified text editor. So no, it did not work. But here's the catch. I think the technology evolved a lot. And I'll tell you what, I was using myself a tool called Proto.io a couple of years ago to do version 1.0 of the Novacene app as a prototype that I could show to my developers so they can build it for me. And that was not a no code, it was more a low code because I could program some logic to create some interactions and behaviors. And I was really impressed. And I'm a guy, I like the code. I like to get my hands dirty, but I was quite impressed with how far it got me before we went to engineering. So before I talk about the case studies, I just want to mention two concepts that underpin my presentation here. The first one is interdisciplinary collaboration, and the second one is managing complex projects, and how both really will support the presentation. I gotta take you back to the 1980s, and that's me wearing a handsome red jacket on that rather cool vehicle. My dad is next to me. This must be, judging by my size and age there, looks like it's the late 70s. And one day I was with my uncle and he was fixing an engine. I think it was a small RV that he had. And he said to me, the reason why I can fix this even though I'm not a mechanic is because I know a little bit about a lot of things, okay? And he was fixing it, and then he said something that stayed with me. This is 40 years later. It totally stayed with me. He said, you know what, Marcelo, in the future, you're gonna have people that are going to specialize, not in this side of the engine, but the component inside of this component of the engine. And they won't be able to work across the stack, across the engine in a wide space. And that stayed with me. And you know what? I think he was right. I think he was right. I think the world today, we have specialists, and I'm sure that many of you here and many of you on Zoom are very specialized and very laser focused and deep knowledge about specific things. And if you add to that the fact that technology is everywhere and it enters every domain, especially software, you end up with a situation where you inevitably will have to collaborate across disciplines, across expertise silos. And I love this excerpt from a paper called Jack of All Trades and Master of Knowledge, the role of generalists in novel knowledge integration. And the researchers say that when they wrote this paper, they were motivated by a paradox where impactful discoveries are the result of diverse knowledge input, yet achieving diversification is increasingly difficult as knowledge accumulation leads to division into narrower knowledge areas and increased specialization. I love how that captures the view around specialists and generalists. The second thing is complex project management. And for this one, I want to borrow from Andrew Ng and a recent issue of The Batch, his newsletter, where he goes, compared to traditional software that begins with a specification and ends with a deliverable to match, machine learning systems present a variety of unique challenges. And then he goes on to say, we don't know how accurate the system will be in advance. We might need a costly initial data collection phase. After getting the initial data set, we might come back and ask for more or better data. And we might ask for this over and over. So while a traditional IT software project looks like a linear 3-step process where you plan, you build, you deliver, and you celebrate, machine learning has a lot more caffeine in it. You plan, you build, you go back to the drawing board, you reformulate your hypotheses, you think of the problem from a different angle, and sometimes, worst cases, your POC never leaves the shelf or sees the light of day in production. Is there a better way? I think so. And for that, we need better collaboration. And that brings me to the 2 case studies I wanted to talk about. The first one is a project called the Journalism Representation Index. And in this case, the experts are journalists and professors from Toronto Metropolitan University. And just a quick brief about the project. The Journalism Representation Index, or JERI, offers news outlets and media watchdogs a rare view of how journalists fare in representing all of the key stakeholders in stories of heightened public interest. That's the URL for the project. If you want to check it out, really interesting. They came to us and they said, we want to know how representative a news article is based on who is quoted as a source. Now, what does that mean? Let me parse that out. So representative in this case means that, let's say, for instance, you have an article and the only source quoted in the article is the Toronto Chief of Police, then that article might be one-sided. And the framing of the news piece might have an authority sort of perspective, right? Whereas if you have another news article and you have the Toronto Chief of Police, but you also have an expert from academia, and you have a political figure, civil society, and a celebrity, now all of a sudden you have a more representative news article. So they said to us, can you write some code, an algorithm that help us compute the representativeness of this article? And our data scientist said, okay, well, we think that this is a 2-step pipeline. We're gonna approach it as a fine-tuned BERT, NER, and as a second step, we're gonna do a multi-class classification where we're gonna assign a class from the very different classes that we have, whether somebody's an authority, a political figure, a celebrity, and et cetera. So they built the pipeline and they deployed it onto the app, and the app allowed the journalists to upload new news articles and put them through the pipeline and see the results, see the predictions that the algorithm was outputting. They were able, the journalists, they were able to export that data, annotate, and provide corrections to that data, feed it back to the data science team, retrain the models. And it empowered the journalists and the research analysts, the research assistants at the university, to get involved with the quality assurance and the quality control of the product that we were building. And that helped, and most importantly, I think in my view, is that it helped develop a more precise communication between the 2 teams that were coming from very different backgrounds, something that is really difficult in practicality to achieve. The outcome is that the initial assumption from the data science team was just too simple. The solution wasn't enough. The deeper understanding of article structure from a journalistic point of view gave the data scientist new nuance and understood the challenges that came with that nuance. And it allowed them to revisit the initial assumption. So what started as a 2-step pipeline, it ended up being a 4-step pipeline where we first extract person using an NER, then we have a source detection to determine whether that person is in fact a source in the article, because the article could be talking about somebody, but it's not quoted in the article. A source type classification, that was the second step on the old pipeline, and co-reference resolution, which is a really interesting problem, where in a news article, we have somebody who's introduced in the first paragraph, but is not quoted until later in the article. And then when they're quoted, there's no context as to who they are. So how do we solve that disconnected context problem? Or somebody might be introduced by name and last name and then refer to them as she or him or her or he. How do we count that? The second project was an analysis of open-ended survey responses, many different surveys. And in this case, the expert is a research analyst at a public engagement and opinion research unit at the Government of Canada. The unit, just briefly to give you context, engages Canadians and stakeholders on various issues by conducting public engagement activities, such as consultations, public opinion research, and by using external advisory bodies. Here's a URL if you want to check out more about that unit. They came to us and they said, we want to understand what people think about various subjects. Fairly blanket statement, right? If there's some. But anyway, so NLP, engineers look at this and they say, well, we think is text classification, clustering, topic modeling, sentiment analysis, that tool set, that type of tool set to that problem. So what they did is that they used the no-code platform to test a few unsupervised models against different data sets to understand the degree to which these models generalize well enough to provide background. Yes, sir.
5 minutes.
Oh, I got to speed up. So at one point, the analyst said, well, I need a word cloud, but that really what they were asking was, we need a context-aware time frequency analysis tool so that we can actually make sense of the data. And this interaction created opportunities for R&D exploration to generalize models through context. The outcome is that it created a close working relationship between the analyst and the data science team. The data scientists got embedded into the analyst world, both created a better understanding of their way of thinking of each other's world and just better communication all around. The conclusion is that in both cases, and this is probably the most important bullet in my PowerPoint, if you ask me, is that initially domain experts expressed their need within the confines of what they understood to be possible. They came to you and they said, we want you to build this for me, whereas they should have come to you and say, we want to achieve this outcome or solve this problem, and let the collaboration dictate how we're going to get there. So that's, that to me is like really the underscoring side of it. In both cases, better collaboration, better communication, and looking at the pain points as the experts were experiencing through the no-code tool gave the data science team incredible opportunities to see specifically what was frustrating them and where solutions were inadequate. Teams sharpened their communication and it broke down barriers between silos. I know it's cliche, but it's exciting when you see it in real life materialize in front of you. I'm going to skip bonus and I'm going to say the summary is that I used to think no-code tools were limiting. They made the practice simpler, which is not a good thing. But they create abstractions that can be helpful, put diverse teams in a level playing field, and allow data scientists to do more interesting work by leveraging things that are already done for them. So cheers to a world with less caffeine and more celebration. Thank you, everyone.